Now then, Fahrenheit versus Celsius versus Kelvin and U.S. Imperial aka U.S. Customary versus Metric versus SI. Which is the best? Practical use and application. First, understand that we humans by nature are survivalists. We have been tuned to what we need to survive ever since the early days. As such, and contrary to what many may say, our minds have a very tough time understanding abstract realities like numbers, which is why money and counting high numbers are such hard things for humans and why we make so many simple mistakes. How much is $1,000, or what does 1,000 stones look like? Thus one must associate such things with something which has that value, say a rare $1,000 cat. But how is that relevant to a house's cost? How many rare cats is a house worth? For even bigger numbers like million, billion, trillion, quadrillion, quintillion, etc., or even those with many decimal places like 3.875619, it gets even worse. For such big and or precise numbers, one must perform math, and even if you can do the math and come to the correct answer, that truth does not mean that you can truly understand and comprehend such numbers. Our brains are tuned for survival, and as such are tuned for what I shall call survival numbers, seeable numbers if you will, e.g., how many people live in my house/hut? How many children do I have playing in the field? How many wolves must we fight to live here safely? After becoming a big enough number, it doesn't really matter anymore. Phrases and words like a bunch or more than I can count in my head do just fine. Between 10 and 10,000 charging elephants, what's the significant difference? If you don't get out of the way in time, you are going to be crushed either way. The imperial system's design allows our minds to handle measurements easily and efficiently. Never do you need to visualize more than 11 inches. With the metric system, you need to measure things up to and usually exceeding 100 centimeters. That's extremely challenging for our minds to comprehend and understand. Despite the claims made from folks who are for the metric and or SI systems, neither those nor the imperial/customary systems are based upon arbitrary numbers. The metric and SI systems are based largely upon something abstract, specifically numbers, to make conversion faster. The imperial/customary system is based upon what we actually use measurements for, visualization. Thus, the metric and SI systems are great for science and math, but they stink for everyday life. That's because of how they are designed. The metric and SI systems are designed to be easy to convert and to put into math equations. But the imperial system is designed to be the most practical in the ways which we use them the most in our day-to-day lives. In everyday life, the main reason which you need something measured is so that you can visualize it, estimate it, or compare it with something else. Is the drawer big enough? How big was that bear which you saw? How long is that road? There are situations in life in which things are communicated which require visualization. Measurements are an important element of that. If someone tells you how long a tree branch is, you need to be able to visualize that. If the weatherman says that it will be 0 degrees Fahrenheit tomorrow, you need a mental temperature reference of that to mentally feel that. If you infer from a map the given distance of your destination, you need to understand how far away that is. To visualize anything, we require a sufficient reference point. Our brains are different from our computers. Computers rely on algorithms, programs, and rigid methodologies. Our brains rely on associations. They are capable of understanding certain things, and the metric and SI systems don't take these things into account. A common example is height, the most common use of measurement in everyday life. What's his growth and such? The most common use of inches and feet is height, but the metric and SI systems are very bad with measuring people. Outside of the USA, people are measured by the centimeter, which is inefficient and terrible. Much effort and discipline is required before the brain can work with and visualize 133 centimeters. In our day-to-day lives, the centimeter is too tiny and the meter is too big, but the foot and the inch are easy to work with because they are the best ranges to measure most, if not all, things in everyday life. The imperial system is sensible. Example, extend your left arm all the way to the left side of your body with fingers extended completely and put your right fist on the center of your chest. From your left hand's tip to where your right fist is, assuming that you are an average size adult, you have made a yard or something very close to it. Your finger bone, say from a fingertip to the closest pin, is an inch or very close. There are many other examples. These units are easy because we can see them daily. Some may then say that there is nothing between the yard and the mile. Exactly. When is the last time which yards were too small for non-driving purposes? But even then, the mile isn't the preferred unit unless it's about geography, we're in geography class, or we're using maps. We use time instead because it's more effective and relevant. Distance is very relative in light of the fact that it can be affected by a number of different factors. How many hours is the typical question, so we use time as the main unit. It's about an hour away. The main thing longer than a yard which need be visualized is a building. In human history, these are relatively new. We did not have these a century ago. Obviously, feet, yards, and the meter are too short, and the mile and kilometer are too huge, so we use stories. This is the most accurate measurement for a building and is very visualizable because we see it daily. Temperature. Celsius is based upon the freezing and boiling points of water, and Kelvin is based upon absolute zero. That makes sense, right? Well, maybe if you are a scientist, but how do they help us in everyday life? When we talk about the temperature, what are we 90+% of the time talking about? The air. We want to know how hot or cold it is outside on the thermostat or in our refrigerators/freezers. This is why Fahrenheit makes sense and best Celsius. It's based, intentionally or not, upon the temperatures which we humans can tolerate. If it is higher than 100 degrees Fahrenheit or below 0 degrees Fahrenheit outside, then stay inside. That's the typical range of weather. In Celsius, that is approximately -18 degrees to +38 degrees, and it relies heavily on decimals because it's a much larger range of temperature per degree. Anything hotter than about 120 degrees Fahrenheit or colder than about -10 degrees Fahrenheit is, any way you look at it, just a number. Something which the average person can't possibly comprehend because they've never experienced it. Can you comprehend what 200 degrees Celsius would feel like? You can't, because you'd be fried. The only exception which I can think of is cooking with the ovens. Even then, it's not something which we need to really visualize or perceive. If the oven needs to be set to 375 degrees Fahrenheit, just set the oven to that number. If water needs to be boiled, heat it on high until it boils. Problem solved. If water needs to be frozen, put it into the freezer until it freezes. Problem solved. Water will never get hotter than its boiling point, nor will water ever get colder than its freezing point. Under normal circumstances, that is. So the precise temperature is completely insignificant. The imperial system's units of teaspoons, cups, pints, quarts, gallons, etc. are based upon what one can use to effectively and efficiently follow recipes and kitchen hints the best. So unless you are a scientist, it's unlikely that you use volume measurements outside the kitchen.